In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery that has astronomers around the world in awe. A few weeks ago, the telescope discovered the earliest known galaxy in the universe. But now, it has detected something even more massive, a supermassive black hole moving away from its galaxy at an incredible speed of 4 million miles per hour. In a stunning turn of events, NASA's James Webb Space Telescope, JWST, has once again amazed the scientific world with a discovery that defies long-held beliefs about the nature of our universe. Just weeks ago, JWST detected the earliest known galaxy ever recorded. But now, it has captured something even more extraordinary, a supermassive black hole traveling through space at an astonishing speed of 4 million miles per hour, tearing through the cosmos in a way never witnessed before. This discovery has set off waves of astonishment among astronomers and space enthusiasts alike. It's not just the speed that's jaw-dropping. It's what this black hole is doing. Instead of consuming everything in its path, as black holes are typically known to do, this one is leaving behind a trail of newly formed stars. Yes, a black hole that's creating stars. This phenomenon has never been observed before, and it contradicts the traditional understanding of black holes as inescapable cosmic vacuums. According to a recently published paper in Astrophysical Journal Letters by a team led by geoastronomy Professor Banerjee, this black hole is interacting with interstellar gas as it hurtles through space, compressing and cooling the gas to form new stars. This massive stellar trail stretches a staggering 200,000 light-years long, twice the diameter of our own Milky Way galaxy. NASA's Hubble Space Telescope has confirmed this finding as well, adding credibility to what some initially thought might be an observational anomaly. Scientists now believe that when a supermassive black hole is ejected from its galaxy, possibly due to gravitational interactions during galactic mergers, it can stimulate star formation in its wake if conditions are right. But this is only the beginning. Another astonishing announcement by NASA involves the spectacular galactic merger known as ARP-220. Recently observed in exquisite detail by JWST, ARP-220 is located approximately 250 million light-years away in the constellation Serpens and is considered one of the brightest nearby galactic collisions ever recorded. Classified as an ultraluminous infrared galaxy, it emits light with a brightness equivalent to 1 trillion suns compared to our Milky Way's modest 10 billion. ARP-220 is the product of two spiral galaxies colliding around 700 million years ago. The collision triggered an intense starburst activity, forming a dense, chaotic core about 5,000 light-years across, packed with more than 200 massive star clusters. What's even more astonishing is that this compact region contains nearly as much gas as our entire galaxy, tightly compressed into a much smaller volume. Earlier observations using radio telescopes revealed nearly 100 supernova remnants within just 500 light-years. The Hubble Space Telescope later identified two separate galactic cores about 1,200 light-years apart, each surrounded by a rotating ring of infrared-emitting stars. Now, thanks to JWST's unparalleled infrared sensitivity, we can see the full complexity of this merger, including faint tidal tails stretching into space, formed by the intense gravitational tug-of-war between the colliding galaxies. Filaments of red, orange, and ochre observed in the images represent organic materials and cosmic dust, ingredients that play a vital role in star and planet formation. The sheer amount of raw matter and energy visible in this merger underscores just how transformative galactic collisions can. Yet, as remarkable as these findings are, JWST has done something even more profound. It has changed how we view the early universe itself. Astronomers using the telescope have identified primordial galaxies that formed just 300 to 500 million years after the Big Bang. At first, some researchers doubted the validity of the data, suspecting these were closer galaxies appearing distant due to trickery in redshift measurements. But after further peer review and confirmation, it was made clear these galaxies are real, and they are some of the oldest and largest ever recorded. The light from these galaxies has taken 13.5 billion years to reach us, offering a direct view into a time when the universe was less than 5% of its current age. What's baffling is that many of these galaxies are up to 10 times more massive than the Milky Way despite forming in a very short cosmic window. This rapid development defies the existing models of cosmic evolution, which suggest galaxies need billions of years to accumulate such mass. According to renowned physicist Myoku, this new evidence is challenging everything we thought we knew about the early universe. The galaxies discovered by JWST are far too massive, too mature, and too evolved for their age. It's as if we've opened a history book and discovered entire chapters that were never written, he remarked. These findings also put pressure on the Big Bang theory and the standard cosmological model. While the Big Bang is still the leading explanation for the origin of the universe, these anomalies highlight significant gaps. Some scientists argue that early dark energy, unknown particle physics, or even modifications to Einstein's theory of general relativity might be needed to explain how these galaxies evolved so rapidly. Others are going further, exploring alternative cosmologies such as the cyclical universe theory or bounce models, which propose that the universe may have undergone multiple cycles of expansion and contraction long before the current Big Bang. If confirmed, such models could drastically rewrite our understanding of time, space, and origin itself. In another tweet from NASA, the agency shared details of a galaxy cluster forming just 650 million years after the Big Bang. This young protocluster appears to be evolving into a structure similar to the massive coma cluster we see in the nearby universe. Astronomers have used JWST to measure the velocities of 7 galaxies within this cluster, confirming that they are gravitationally bound and forming what will become a massive galactic assembly. NASA likened these young galaxies to droplets of water in separate streams destined to merge into one colossal cosmic river. These findings underscore a central theme in modern astronomy. The early universe was far more dynamic and evolved than anyone had predicted. While this all unfolds in the vast silence of space, back on Earth, scientists and engineers are already planning the next generation of telescopes to follow in JWST's footsteps. The Nancy Grace Roman Space Telescope, LUVOIR, and HABEX are all in development and aim to answer key questions about dark energy, exoplanets, and even the potential for life beyond Earth. JWST has already begun analyzing exoplanet atmospheres using its advanced spectrometers, identifying signs of water vapor, methane, and carbon dioxide on distant worlds orbiting stars light years away. These findings move us closer to answering one of the oldest questions in human history: are we alone in the universe? Every image captured, every spectrum recorded, and every redshift measured by JWST pushes the boundaries of human knowledge. It's not just observing stars and galaxies. It's challenging what we thought was possible. As the telescope continues its mission, one thing is clear: we are standing at the threshold of a new era in cosmic exploration. An era that compels us to question, rethink, and perhaps redefine our most fundamental assumptions about the cosmos. So, what are your thoughts on these groundbreaking discoveries? Could our understanding of the universe's origins be incomplete? Share your insights in the comments below. Don't forget to like, subscribe, and click the notification bell to stay updated with our latest content. Here at Discovery 2.0, we'll continue to bring you deep dives into the most astonishing revelations from space and beyond. Thank you for watching, and remember, the universe has many more secrets to reveal. Stay curious.